So basically this is my two pictures that I have here, okay? Now, so if you combine those two pictures, that's the total volume of the pool. And I separate them just so you can see. So the total volume here, okay, the total volume would be this sort of triangular looking plus that rectangular. So let's do, so it's the bottom volume, which I call this, let's say A, volume of A plus volume of B, and let's call this B. Well, we know what the volume of that is. The volume will be, it's the height which is 1, okay? The width, this was 12, the depth is 6. So volume is 12 times 6 times 1. Okay. And for the volume of A now, since it's triangular, it's going to be 1/2. Now keep in mind that if this here is 1, the total, if you look at the question, right, the total 3 meters deep. So if I combine, this is 1, then this has to be 2, because the total when I put them together was 3 meters deep, okay? And 1 meter deep at the shallow. Well, it doesn't matter with the shallow because this is already cut out here, okay? This is still 6 and this is still 12. So it will be 1/2 times 2 times 12 times 6. So if you multiply this out and add them, we'll get 144, excuse me, 144 meters cube. So that's the maximum volume this can be filled to. Now currently in this example, it says that when water is pumped in a pool and there is 1 meter of water at the deep end. So if there is 1 meter of water at the deep end, that means we only have water about here, okay? Not the total height. So the volume, okay, of 1 meter of water will be 1/2 times 1, because we only have 1 meter height, times 6 times 6. Okay. Now you're probably wondering, well, before we use 1/2 times 2 times 12 times 6. Well, here is the explanation why, where we're getting this 6 from. This 6, let's say, is the same as this 6, which is the same as sorry, my iPad was freezing up. So, which is the same as this 6 here, right? The depth of it, if you want to call that the depth, is still 6, but the width here is 12. The total distance is 12. But if this is only filled halfway, then we're assuming that halfway here is full, and that's where we're getting the second 6 from. Okay. So if we fill in those numbers, we have, this now becomes 18 meters cube. Okay. So for part A, when they ask you for what percentage of the pool is filled, then the percentage of pool filled is equal to 18 over 144, times 100 because we need percent, right? Times 100%. And that is equal to 12.5%. So only 12.5% of the pool is filled when there's 1 meter of water at the back end, okay, or in the pool. So that's part A. So let's draw a picture back of this pool that we have here, because it's very important we understand what the picture is. So I'm not a good artist, but we'll try. It's the bottom, it's the height, and our pool is out this way. Okay. And what's happening is that we have water over here right now, let's see. Okay, that's the water. So let's plug in some numbers that we possibly have. Okay, we know that this here is 1 because we have in the problem it says that there is 1 meter of water, right? So we have 1 meter of water. Now, if we look at this portion here is sort of that shaded area that maybe if I can trace that out with a pen, sort of looks like a triangle, right? Okay. So if we look at the, well, I don't want to give away the formula. Let's go back and look at the problem. The problem is giving you a very, very important piece of information. Water is being pumped into the pool, okay? Water is pumped into the pool at 1/2 cubic meter per minute. So what does this really tell you? Cubic meter per minute. Cubic meter per minute. Well, it's something over time, okay? So it's something over time. So time is changing. And cubic meter, cube, is volume. So that is dV dt. So dV dt is 1/2. Okay? So that means that will help us here. dV dt, this is given. dV dt is equal to 1/2 when, okay, if you look at this triangle from a sideway, this is sort of the height or the base of the triangle, okay? When B is equal to 1, okay? If you take this triangle out and you draw it this way, this is 1, okay? And the height, we know, was, in the previous problem was 6, but we don't need that here right now. So now V, let's look at the volume of this shape. V is 1/2. Now let's see. Now if water is being pumped into this shape here, B is not a constant. If I pour a little bit of water, that will be the height. If I pour some more water, that will be the height. If I pour some more. So B is changing. So we leave it as B. Okay. Now the height. The height will also be changed because if you're pouring this much water, this is your height. If you're pouring more, the height change. So H also stays. But what's not changing, the distance across here, right? That distance we know was 6. So that doesn't change, that is still 6. So V turns out to be 3BH. Now, if you remember, this is not going to be very easy to take the derivative of it because we have 2 unknowns. So it's better if we could write this with 1 letter. And we could, because if you remember from similar triangles from intermediate algebra, the height is proportion or in proportion to the base. And for this triangle, the height is 12 and the base is 2, which we drew up here. Okay, the height is 12, the base is 2. So we can solve here for h. H is going to be 6b. So I can replace h here with 6b. So v is equal to 3b times 6b, which is equal to 18b squared. And now if we take the derivative of both sides, dv with respect to time, this will be, bring the 2 out, 36b to the 1, okay, db dt, because the variable here didn't match. Now remember, you were giving, right? You were given dv dt, okay, and you were also given b. So if we go back, dv dt is 1/2, so this is 1/2, and b is equal to 1. So if we plug those in, we have 1/2 is equal to 36 times 1 db dt. So 1/2 is equal to 36 dB dt. Okay. And we can solve for dB dt. So we can solve for dB dt. So this is the same as 1/2 divided by 36 is equal to dB dt. And 1/2 divided by 36, that's the same as 1, 2, so it's 1 over 72 is equal to dB dt. Now, keep in mind, what do we learn? We're looking at something with time because we need units. And this measurements for this here was in terms of meters, I believe. Yes, everything, all the sides was meters. So the answer here will be 1 over 72, okay, meters per minute. And that is my dB dt. Okay, so I think once you have a good sense, so this is our final answer here. Oops, this is the final answer for our problem. Okay, and once you have an understanding of what the problem, the picture of the problem, I think it makes more sense. Okay, I hope this was helpful to you. Yeah.